All right, let's talk about this. So, first of all, I love this unit. Because I just think it's a good change. It's like we go from numeracy, and numeracy is really important. Geometry and understanding of shapes is super important. You can think of like landscaper. If you're a designer, use geometry all the time. If you're a builder, okay, an artist. I mean, spatial awareness and understanding of shapes and geometric functions is a pretty critical element in our lives as humans. So it's a pretty neat unit. And it gives us a break from the numeracy part. So you should have read pages 25, 26, and 27. Go ahead and talk to your partner about those pages, what they were about. Go.
Read it.
Yeah, you remember this? Remember what they called those words they used? We didn't use small or bigger per se. Do you remember?
Two kids making a computer game.
So, I was listening to Radana talk about the computer game that these kids are designing, and they've got wumps, and they've got a family of wumps. How exciting! And they are reducing, and they are enlarging the wumps. So, what does that word reduce mean? Yeah, make something smaller. And enlarge means to make it bigger. So that brings us to what we're going to talk about today, which is this I can statement of solving scale drawings. A scale is where you make something bigger or smaller. And we're going to do geometric figures. And take a guess what the geometric figures are going to be today.
Rectangle.
Wumps.
Oh yeah, wumps.
They're wumps, man.
I love wumps.
Oh, we get to use the computer?
What is the definition of wump? They look like triangles. Wumps just like the triangles.
So, but they are a geometric figure, and we're going to enlarge and we're going to reduce them, and there'll be a scale factor involved, which helps us make this scale drawing. So to go back to our warm-up, talk to your partner about the questions that are on the board, about the rectangle that's up there. Go.
Are we supposed to do the triangle or the entire thing? I got 10.
Rectangle.
Wait, we were only supposed I kept saying triangle because of the lumps. 3 plus 3 equals...
All right. So, perimeter. What is the perimeter of our rectangle, Cody?
It's 30, 42.
We're talking about this rectangle.
Oh, just the rectangle? Yeah.
You didn't see this? You thought this?
Yeah.
You're the... So Josh did the same thing, and you guys are the only... There's one other person in another class that started, and they were like, wait a minute, and they looked and they saw that rectangle.
I thought that was supposed to
Good work, Cody. So, this is 10 units. How do I know? It's length, okay, plus width, plus length, plus width. Perimeter is easy. It's a distance around something. So what is the area? And how do we calculate area? Quinn?
6, you just multiply like
Length times width. So we're going to get the length is 3 times the width, which is 2, and then we get 6 units. And there's one more thing. Square, not cube, square. Now that square is going to come in handy here in a second when we start talking about scale. Can you make another one that's 50% the size? And what does that mean? What does 50% mean? Radana?
Well, it means half.
Half. It means 0.5. 0.5 and 50%, and I want you to write this down. They're equal to each other. They're the same. 0.5 equals 50%. How do I know it's 50%? All I do is there's an imaginary decimal, and you basically just pull it over 2 spots. Yes?
And then what I wrote was, I can make one that is 50% of the size. The area would be 3 units, and the perimeter would be 5 units.
Ooh, close. Uh-huh. So ready? If this is 50%, ready? What is 0.5 times 2? 1. What's 0.5 times 3?
1.5.
So this is 1 by 1.5. So what is the perimeter now? This would be 3, and this would be 2, which is, so the perimeter is equal to 5. This perimeter was 10, and we said the area was 6. The area here is 1.5.
I can explain that.
Hold on. Because it's length times width. So check this out. This is what's interesting here. Perimeter. Is this half? It was 10, now it's 5. Yeah. But what happened to the area? Talk to your partner. Talk to your partner. Why is it a fourth? Talk to your partner.
The original rectangle.
Looks like it, doesn't it?
It is. It is, but why? Why did it go down so much?
Why did you ask the
No.
Because the area is only what's in the side.
Yes, that's good. But why? Why does it go down so much? So,
The size of the area.
why? So, yeah, the perimeter, Cody, goes to 50%, right? It changes by half. It goes from 10 to 5. But the area, as Ben pointed out before I wanted him to, it goes from 6 to 1.5, which is a fourth of the size.
Wait.
Why is that? Yeah.
I think it's because you're taking down both numbers by half, not just one. So it would be half of each number times half, which is like...
It's half of a half, right? It's this. It's 1/2 times 1/2, which equals 1/4, right? I'm taking a half of my length, and I'm taking a half of my width. And so my area goes down by a fourth. So now that you know that, yeah, talk to your partner about this. Go. All right, so if we look at this, can you make one that is 200% bigger?
Yes,
What is Quinn? What's 200% as a number? 2, right? I just take that decimal, 1, 2, move it over to 2. So I want you to write this down because this is a pretty important concept to remember, is that 200% equals 2. They're the same. Okay. So here we have a perimeter of 10. So if it's twice as big, which is what it says, 2 times, does 20 make sense? Yeah, it does. Totally makes sense. But the area went from 6 to 24. Talk to your partner about what Olive was talking about before. Go.
Wait, this is my problem. Is it okay that I just did it in one try? Like in one? Okay. So,
So Chris, what I was saying is I doubled this side and I doubled that side, right? So I made this twice as big. I made that twice as big. So my area comes out to be 4 times bigger. And this is why. Remember what I was telling you? When we put a squared on the end of that, it's basically like 2 squared. It's like taking 1/2 and squaring it. 1/2 times 1/2. Right? So if I made something 3 times bigger, how much bigger would the area be?
6 times. No.
It's a square. If I made it 3 times bigger, the area would be 9 times bigger, because that would be 3 squared. Questions about any of this? Okay. Grades on Infinite Campus, you guys know that. And then retakes, I'm going to start retakes tomorrow. I'll be here at 7. But don't come in unless you've done one of these. Okay? It's the retake form. The reason why I make you do this is that I'm not going to have you come in, retake a test, when I could be doing something different, you could be doing something different, if you don't know the material or the mistakes that you made. I want you to do well on this. And I want you to use your time wisely and my time wisely. This helps me gauge what you know, what you don't know, and how to help you so you can be more successful on the retake. Okay, so it's a benefit for you, and it's a benefit for me. Just making sure that we all use our time wisely, as well as making sure that I know that you know the material before you retake the test. So if you want to retake the test, you have to do one of these. Some of you don't get a choice. Okay? So, but those are back here if you want to retake. Yes?
What if we don't have ours done? Can we come in tomorrow morning and finish it?
You can come in the morning and finish it. Yep, and I can help you with it. Yep. But you don't have to be here at 7. That might take you a half an hour, so you could come at like 7:20 or something. The test will take you around 40 minutes to 55 minutes. So you do need that whole time.
So we're coming early.
And I'll be here. Okay? I'll be here tomorrow. So you can go home, you can practice. I posted, Scarlett, I posted a copy of the test so you can practice and get tons of results back. You can take it as much as you want. You can't take the original one because I need that data. I want to save that data for next year's class, and I can compare to see if I'm doing a better job or worse job, or I need to make improvements. Any questions about any of this? Okay. As for the homework,
I did it.
I'm going to go over it because we're running out of time today. We're not going to talk about it. There's only a couple kids, and I'll try to hit you during when I'm circulating. Please get out your 2.1. No. Learning.
Yesterday?
Today.
I don't know.
Man, you're so confused.
This was the homework.
I like having you up front, Josh.
It's not as bad as that map thing in Mr. Red's class. I sat next to Adonna anytime I didn't know something. Adonna!
That's so annoying.
She told me about that.
Yeah.
All right. Okay.
Every time you finish it, it's terrible. I hate it. It kept telling me.
All right, here we go. So back to math. Back to math. So we're making these wumps. You can see 2.1. We're going back to that I can statement. Scale drawings. Scale drawings can become bigger. Scale drawings can become smaller. And the thing about a scale drawing is that not one part of it is going to be bigger, right? It all gets bigger at the same amount, and that's called the scale. Or it all gets smaller according to the same amount. So we're going to be making some scale wumps, and we're going to be plotting these on a coordinate plane. There are 4 planes in a coordinate plane. We're going to use the positive plane. Okay, this is positive x and positive y. Over here is negative x and positive y, right? And this is the negative plane. Okay, and down here we have the negative y and positive x. But we're just going to use the positive coordinate plane. We have x and y coordinates, and this is how I know which is my x-axis, my y-axis. Really basic. My goodness, why is it doing this? It's like I just got to go there, boom, done. So y is taller than x, so it goes up and down. That's basically how I've always remembered it from like elementary school. Y is taller than x, so it must be the one that goes up and down.
Wait, what if they're the same size?
They're not the same size. If you think about the alphabet, y is much taller than x.
Well, y is before x too.
Okay, so
Sorry, my bad.
Plotting these points. I have point A, B, C, D, and I don't know why it doesn't do that on my computer, but it's doing it up here. E. So A is 2, 4. This is what it always means in coordinate points. Go over so many and up. Over and up. So I want you to write over and up. And you can put an X under over and a Y under up. So I go over 2, up 4. Make a dot. B, go over 4, up 8. I want you and your partner to do the next 3. C, D, and E. Go.
Over 8.
Okay, this is not a wump. We are not making wumps yet, but you will. So this is, you notice I labeled my points? The reason why is that if you make a mistake, you can go back and find where that point is very easy. If you don't label them, it's really hard to go back and correct a mistake. Because you can't really double check them. So I connect my points. There I have this geometric shape. And that was part of our I can statement, is having these geometric shapes. So now I am going to make a new shape. I want you guys to write original above this one. Okay, and this is going to be called the reduced, because I am going to make this one smaller by 0.5, by a scale of 50%. This is reduced by 50%. And it's not just the x is reduced by 50, but the y is too. They both are. So here you can see my scale factor. Since these are x and y, I take my x, which is 2, I put it in, and I get 1. 2 times 0.5 is 1. 0.5 times 4 is 2. Go ahead and fill in the rest of these with your partner. So use this scale factor of 0.5.
Yeah.
Okay. Take your 2. I put it in. 0.5 times 2. 1.
So
Okay.
it's basically divided by 2.
It's multiple. Just don't. Yeah. It's multiply. So this is multiplied by 0.5.
This would be 2.
Yes. So now I plot these points. So go ahead and plot these points. I go over, up. Over, up. And I'm going to label them. That way if I make a mistake, it's easier to find. and then connect them. So it is a similar shape. So similar shape means corresponding sides. The sides are in the same position, so to say. They could be rotated, but they're in the same positions. They're just either smaller or bigger. Here they're smaller. But that whole shape is proportional to the original shape. It's 50% smaller. It also has corresponding angles. All the angles are exactly the same. Okay? And it is the same shape. So reducing figures and enlarging figures. If you're like an architect or a city planner, you're always thinking about scale a lot. And this is kind of what they do, except they'll do it with like a model house or a drawing of a new like mall or a new store. Okay, they'll have it drawn out to like every aisle, and it will be like a scale, like when you open a map, you see scale. This is kind of what we're doing. We're using a scale to create these WUMPs. You have a piece of paper that looks like this. This is how you can record your points for today. Okay, you can see there's points all the way up to X. You are only going to do mug, zug, and lug, the first three. Here they are. I try to give you some help so you don't have to make. Here's mug and zug. On the back is lug. Now, lug has a mistake. I made his y-axis, or her y-axis, too big. I should have made the x-axis way bigger. So you're going to have to add on to your x-axis in order to make lug. Yep. Okay. Here, this is our work for today. We are on page 28 and 29. No, you are. Trust me. Yeah. No, it's not homework. It's 28 and 29. Don't worry about homework right now.
Wait, should we do AL first?
No. This is what we're doing now.
Wait, you're confusing us.
It says work on the following problems in order as they are listed.
Get red.
Problem 2.1 on page 28 and 29.
And we're doing this.
That's what you're doing right now.
What?
Just go ahead and read 28 and 29.
So we do A first.
Just read 28 and 29. Those are papers, resources
We
you're
now
going to
need to
need.
compare the shapes.
So I would like you to sit back in your spot, Scarlett. Move that chair and sit right on your desk.
Oh, so we compare the two shapes.
Okay, let's go. Oh, I get it.
So we do A first.
You do mug first. You do A, but yes, read A. It's in here, 28, 29.
My best bud.
This is part 1. Part 3, part 4. Yeah. Hey, Olive asked a really good question. She said, what's part 1, part 2, part 3, part 4? This is part 1. This is part 2, part 3, part 4.
Parkour. Parkour. A.
Vanessa, you need to go sit in the far corner, it looks like.
Are we doing this right now? Well, those are how many points for mom. You drove along.
Draw. We need to draw a mug.
Is that all? It's 2.
Okay, 0.
Triangular prism.
Label that A. B is 2. Do not do bug. Do not do blood yet. What? Do not do bug or blood.
I don't do bug anyway.
Don't do that. That's why.
I'll bug kick first.
Guys,
Stay focused.
right there, I'm taking a time. So got to the last period.
What? Well, this is nice.
Okay, what do you guys want? Yeah, that's all part A. Yeah.
Okay, what does... I know I already have that. Part 1. I can feed the big triangle. This, copy this.
Illuminati.
Yeah, you do part 1 first.
Okay, and this is all for what?
This is all for mug. That's all for mug. That's all for mug. And that you have to now figure out Zug, like you did earlier. Here's Zug's coordinates.
I don't get... Is Zug just 2 dots?
Come on.
Mug is weird.
Boom. Got
Mug
it.
is weird.
Pretty sure this is the member of the.
Kind of a name is Mug.
Oh.
Don't connect that and that. See how it says start over?
Is this correct?
No, you made a mistake. Figure it
Is this
out.
correct?
Figure it out.
So, this is Farland.
He loves this stuff. Because we needed some engagement. Right?
Yep, that's it. And then you start over for part 2.
We don't.
Mind shape.
You don't connect them. You only connect the dots in part 2.
Mr.
You do. You connect these.
Now we're
And then you start over. Connect those, and then you start over. Make it up.
Part 2. Start.
That's
So now you're not connecting. Now you're only connecting. Oh, but don't. No. Connect them.
No, don't draw down. There's no dot down.
I did that one.
Right? See that?
You're still doing the mud walk.
Oh, well, there's my problem.
Mug's undone.
That'd be easier.
So you don't go over.
Oh, true. Right. Yeah. So look here. You don't want to connect those.
Because it's over, up, over, up.
Oh,
and
yeah.
you
don't want to connect those.
Right? You can
Oh,
go
but
over
Scotia.
negative,
I think
but you don't have any mud.
Did I make them Mug?
For now.
This is so.
Yep.
Oh, I get it. These are his legs.
He's got his nail slide, but these corrected that part.
That's really dumb. Wait a second. What did I just draw? No, I drew Mug.
Did I fix this?
Yeah.
Okay, good. I got
Zug,
scared.
zug, 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 zug.
Beautiful.
Yeah.
Oh, you don't? Okay, so they have to.
Yay!
Uh-oh, you're... Alright, I think I got the same. No. You're just doubling on this.
There's a part 2?
I think that's... Oh, part 2. Dude, like, there was
Yeah, if you get her early, we go
What's
over
your
the
eye?
number.
Mr. McFarland, is this good?
Oh, it's supposed to be 2. Oh, or maybe a hexagon. The other part.
Oh.
Yeah.
I was wondering.
Yes.
Hey, Mr. Mick, what do you do for parts today?
Yeah.
You go over the coordinates, but you don't you don't
Here's the
connect
polygon.
them to.
Because he has straight sides, right?
You don't connect.
He's closed.
You connect those, but you don't connect them.
You start
No,
over,
that's
so you don't
not.
connect.
He's, well, his body.
So like, wait.
Okay.
So like part 2.
Yeah, you're not connecting the dots right now.
Part 2. So you don't
No.
connect it to this last point in this. So you're
Because look, this is 3, 1. Go over 3, up 1. Okay, and then the next one is 5, 1. Go over 5, up 1. So yeah, those can connect.
No.
Okay, you got all these.
His name.
You get here.
His name
this
is Mug
up
the
1.
Okay,
And you
so
go
get it down.
over
Must
6,
say him again.
7.
You're behind.
Over 6, 7. And you're drawing a straight down. You should connect this one to
Drawing zone.
that one.
I'm feeling great. We're making a now.
Because this was
Really,
When you're
point
going to subscribe to my
J, and that's point K.
I really
J goes
don't
to
like
K, and that's the same dot.
Are you
J
sure
goes to
Zug
K,
is?
does that make sense?
Your
You've done it.
Zug is thin, but a lot bigger.
There's no bug or click on it.
Okay, and then this goes
Poly
to
means many.
there, because that's 2 and 7.
Plug
And then the next one is 0, 1,
Wait, we
over 0,
forgot
up
his
1.
hat.
Use the columns for
So then
the
this goes,
use the given rules to find the coordinates of the points.
because this point is K,
Anybody
no,
have a hat?
J, K, L,
Two
M.
X, 2 Y. This means that you multiply each of those coordinates by 2.
That looks like
Point
an
A and love.
So we're supposed to
Right,
do
that's
0,
cool.
1. Because the corresponding reason love would be 0, 2. Because you multiply this.
It's like saying part by shape,
It's
it would
done.
just be bigger.
Yeah,
But you're multiplying
except it's
and Y by
2 times X and 2 times Y. Those are the coordinate rules for that.
So this is Zug is like a bigger column.
Not half.
Yep.
Alright. Alright, let's go.
Coordinate is making sense.
So it's 2 times 2.
This is
I think you can do most of these in there.
well, that's no. I thought he had like one eye. This
Yeah, the Y is the same, right? Y doesn't change at all.
0 times 2. You're not going to use a calculator.
This time I'm not gonna do the because it makes it really
Times 0 is.
Yeah, I want that.
Jay likes geometry.
Oh, I got it.
Hey, so this is
Oh, I
Boy,
see
you
part
put-
2. Okay, I didn't see part 2.
Oh, wait, now what did I see? Part 3. Wow. Wow. I literally changed Oh. That's perfect. With wham. With wham.
Wait, so this is just
Here I go.
okay.
for this one.
3 times 2 is 9.
By 2, right? This by 2, that by 2, that by 2.
Got
And
him.
then same here.
I just got him.
That by 2, that by 2, that by 2.
Okay.
2 times 1 is
Yes, because see, these are X and Y.
5
Yeah.
times 2 is
No.
5 times 2 is
10.
There's times there's math, you know you're doing that math there yet? 10 times 2 is
You take pliers or
you're gonna take 2 is 6 2 keep doing.
What's up, Madonna? You need scarf. Okay, made one mistake. Looks like no, you're missing the point.
What?
This should pen.
You missed it.
It's
6 7.
connected lines that don't belong.
Pretty eyes.
These don't.
No, that's his nose.
And that doesn't count.
That's a huge
So I want you to go to part. Where's N? 2 and 2. O 2. Up 2. And then O over 6 up 2.
Mine is ugly.
P over 6 up
You better
3. That's when you
It's
so
Wait, that was that.
times 0 is?
So for this one, we
Y stays exactly the same.
How do we do B without doing
You need to do, so you did all of that. Use the given to find the coordinates of the points. So now you got to do zug, lug, bug, and glug. I'm only asking you to do zug and lug. There's zug, there's lug. Zug, lug. So just do those two. Okay, you got to figure out those coordinate points now.
Whoa, that's raining.
Well, what's the rule? No?
4, 5, 4, 5.
Look at look. What's the rule?
Oh, times 2.
Times 2 on the x and times 2 on the y. Lug is different. Y stays the same and x is 3.
Bug looks like a serial killer. Don't spoil it out.
Is that you?
Oh, yeah.
Yeah.
So that's why I didn't know.
I'm frustrated. That's frustrating. I had earplugs under, so it was. I'm not on I can hear my voice.
Yeah.
Okay, you have your first mug.
Ooh, I don't like
You got your first mug.
Honestly, I kind of just want to.
You got your first mug. Happy Christmas.
Merry Happy Christmas.
Hey,
Merry Chrysler. Sorry.
Is that your teeth on it?
No, not if the points are fair.
That's not fun.
I want to check out my
You have to make him ferocious. He already is. He looks like a serial killer. He doesn't look ferocious. Mug is my best friend.
So,
So let me guess, he's just 2 times bigger and he's just the same.
it's similar.
Oh, now we
Because
got
everything is exactly the same. It's just twice as big.
I see what you did there.
Now, lug, on the other hand, is not going to be similar.
Plug is not going to be similar?
Oh, right.
Lug is, he is short and wide. That rude.
No, he's a tall.
How dare you call lug short and fat?
times 2 is.
That is rude.
That is so
You wait till his mom and dad find out what you just said.
Oh my gosh.
Oh my
Man, your parents are going to be getting some emails.
Put all of those
My parents have already gotten so many emails. He looks very good.
Got it?
Wait, if he's short and wide, then why is there a log on the y-axis?
I made that was a mistake I said.
Oh, yeah.
He is British.
Wait, you made a mistake on that.
Bug.
Something from here.
We need at least
Yeah. So slow.
There you go. Or I guess you have.
I didn't expect it to be that.
Well,
I should have done
Back to the Future.
I was trying to do that hard.
Short.
You understand that? I don't know that. It's too hard. And that's why your brain goes
I got a mistake.
There we go. Now we're drawing them one at a time.
I'm so close. Not really.
Yeah. You did well.
I got 2 F's.
You do just the point.
Yeah, you just connect those. And you connect those. And just like when you connect those. Part 4, you gotta make those.
They didn't put any animal characters. Like, we're going to recite Why does Mug have to be the main character?
Oh my gosh, because Mug is awesome.
You know, he's just
Except that you normally don't start
he's
with A.
similar to the other characters. All the other characters are bigger. See, I can't do that.
Yeah, Mug is the way
Good practice. Good practice.
Mug is like an OG, man.
Okay, let's go.
Oh my god,
I gotta add
came out of my mouth.
Yeah, you're not this time. Erase that because it's
Okay, what's your last name?
Oh my gosh.
So do you know how to check your email? You do, your school? Okay, so you'll get an invite to the classroom and then you can go on there. That's where you can find all the videos. All the slides are on there. Like, so if you miss school, everything's right there.
This is my free time. It's nap. Oh, it isn't. It's work.
7.
All I do is work.
No, that's you want to just like smile the police. You caught me distracted.
Right, your first one.
Got him.
Quinn Lewis. Ignite.
Can I just turn this on its side? Like this? Can I do this? Yes. We allowed to just turn this on its side. Smaller than you, but you goofed.
Yeah, I know. I was the wrong way.
Everybody, can we just turn our... Oh, that's only one leg. Dang. And do it like that?
That would technically be in the negative x coordinate. Technically speaking. Technically. We're not technically speaking.
What if I change this side? I'm sorry, I don't speak technical, I speak English. What if we just draw because it's the wrong side. I bet you're not. I bet you don't even watch Logan Paul because you're stupid. Yeah, you can watch Logan Paul now. Good. Congratulations. But I made it up on them trainers, fam.
Okay, so look at Zug and look at Mug. Now, remember, as 7th graders, we're beyond just calling something bigger and smaller.
But we call them Mug and Zug.
No. So, what do you notice? When you compare Mug and Zug, what do you see? Okay, they are similar. They're similar because all their angles are exactly the same.
They have corresponding sides.
They have corresponding sides, corresponding angles, and they are exactly the same shape. It's just proportionately they're different sizes. What else?
Zug is 200%.
Zug is 200%. So that means his perimeter is twice as big. So what about his area?
4 times as big.
4 times as big. His area is 4 times as big as, if you were to count up all those boxes, it'd be 4 times Mug's area. Because area operates on a square. It's 2 squared. So if it's 2 times as big, that means he's 4 times bigger. 2 squared. What else do we know? Could we compare it the other way? So what's Mug compared to Zug? 50%. He's 50%. Yeah? Yeah, if Donna's going to say it, she's going to call one of them fat. Because that's what she said earlier. That's really mean.
You're really
mean. Just joking.
That was hard.
That was tough, huh?
Find the mean of 16.6.
Ooh, see? She's so mathematically mean. All right. We're going to work a little bit on this tomorrow, too. Okay, yep, you'll see. That 2.1 and 2.2 go together. This all goes in your learning tab.
This was fun, guys.
Try to make it fun. Okay, 2.1.
This was the best thing. This is too fun.
Okay, here we go. So,
Wait, where do they?
you guys, get your planners out. Learning. Both, all 3. Put them all together. You have 1A, 1B, 1C. This will take a little bit of time, guys. This is more like a 15, 20-minute homework. Grab a piece of graph paper. If you don't have graph paper at home, you will need a piece of graph paper.
Or make your own. I have that.
Or make your own.
That was graph.
No. There's not many points. You're graphing, I think, maybe 8 points or something.
Oh, I thought you meant like making graph.
Oh.
Have you ever used this to graph?
Okay. So you got 1A, 1B, 1C. It's on page 36. So if you don't have graph paper at home, my suggestion is to grab some. We're going to go back to that I can statement. We were making scale drawings. Zug was a scale drawing. He was 200% bigger. Glug is a scale drawing. He has a scale, but Lug was not similar. And we'll talk more about that tomorrow.
Okay, draw and label the original right side. On your exercise, I finished the exercise. You guys have bigger. Okay, I got you. Okay. Yeah, take 2 pieces left and up. Assuming that will happen. Or maybe 17. I come prepared.
Okay, so go to that I can statement. We have a geometric figure. It's a triangle, so it's actually a geometric shape. It's 6 feet tall, 10 feet long. And I'm asking you to draw a new triangle that's 150% bigger.
A square.
6 and what?
10. 10 wide or long, 6 high.
Are we just...
So, 150%, what does that turn into as a number? 1.5. Oh, I won't draw right now. So that turns into 1.5 because that decimal goes 1, 2 places over, so 1.5. Now that I got this 1.5, what do? Times it by the height. So what's 6 times 1.5? 9. So I get a new triangle. So you should have the old triangle because it says draw and label, ABC, 6 by 10. You have that triangle on your exit ticket. And then you're going to have this new triangle that has a 9 foot high, and it can be called ABC too. And then what is the length? 10 times 1.5 is 15. Connect it. Done. And you could put on your paper 150% bigger. Because it is 150% bigger. Now that I said that, hold on. How much bigger is the area?
It's going to be 6 times. 1.5 times.
Yeah, 1.5 times. It's 1.5 times 1.5. It's a square of 1.5. And how much bigger would the perimeter be? 1.5. So whatever you got for your perimeter, times that by 1.5, and you have your new perimeter.
And improved.
Okay? New and improved perimeter. All right, guys, we'll see you later.